My name is Piers Keane. I'm a consultant ophthalmologist at Moorfields Eye Hospital, and I'm a NIHR clinician scientist at the Institute of Ophthalmology at University College London. As a clinician, I specialise in treating retinal diseases such as diabetic retinopathy and age-related macular degeneration, the commonest causes of blindness in the UK and around the world. And as a researcher, I specialise in imaging the eye, in particular something called optical coherence tomography imaging, or OCT. And OCT has revolutionised ophthalmology to the point where at Moorfields we do about 3,000 OCT scans per week, and we've got over 1 million OCT scans in our databases. Now, despite the fact that OCT has revolutionised ophthalmology, we still don't really have a clear understanding of how OCT images are generated from the tissue of the eye. So I think that any models that we can generate that give us a better understanding of OCT image generation will be really, really important. And I think that this is for two reasons. The first is that it'll allow us to get much better understanding of these blinding retinal diseases that I've previously described. And the second is that I think it'll open up a whole range of new and novel applications for this technology, both in ophthalmology and in other areas of medicine. I'll hand you over now to Peter Monroe, who'll give you some additional technical details of the project.
Hi, I'm Peter Monroe. I'm a research fellow in the Department of Medical Physics and Biomedical Engineering. So one of the reasons why OCT images can be hard to interpret is that the eye has many structures which are of a similar dimension to the wavelength of the light used to image them. This is a problem because when light travels through any kind of medium that has structures which are of a size similar to the wavelength, then the light can propagate in a rather complicated way. So I have developed a computational model which calculates how light propagates in biological tissue, and then calculates how that light would be interpreted by an OCT system. And so we can simulate very realistically image formation in OCT. This project involves two main aspects. One is understanding the anatomy of the eye and how to model it optically. The second part is to take the model that I've developed and adapt it to the specific scenario of ophthalmology. This project would suit someone with a background in one of optics, computational mathematics, or computer science, and with an interest in applying these techniques in optical image in ophthalmology. So this is a really exciting project, and it really can only be done at UCL. Why? Because we have Piers Keane working at the Moorfields Eye Hospital. He is a leader in the application of OCT in ophthalmology, and I have developed this model, and this is the only model in existence in the world at this moment. So this is really a unique time and opportunity to do this research.